Hi everyone, welcome back. Today we're going to be continuing with 7.ns.a3, solve real-world problems involving the four operations with rational numbers. So here you want to keep in mind our rules for adding and subtracting integers. Same signs, add and keep, different signs subtract. Keep the sign of the higher number, then it will be exact. Our rules for multiplying and dividing integers, same signs will be equal to a positive number. Different signs will be equal to a negative number. Okay. Our first example, the hour hand of a clock moves negative 30 degrees every hour. How many degrees does it move in 2.5 hours? Okay, so here you have to ask yourself what operation is being represented here. So every hour it's going negative 30 degrees, and you want to know what the change is after 2.5 hours. So if you think about this as repeated addition, so the first hour is negative 30, the second hour it's going to be another negative 30. So we know repeated addition is associated with multiplication. So we're going to multiply negative 30 times 2 1/5. Okay. Now we want to actually go ahead and transfer this fraction, this mixed number, into an improper fraction. So that will give us negative 30 times 2 times 5 is 10 plus 1 is 11 over 5. And I can write my negative 30 as 30 over 1 to make it a fraction as well. So now let's go ahead and apply our rules for multiplying fractions as well as with integers. So I have a negative and a positive so that I know that whenever I multiply, that's going to leave my answer as a negative. Okay, so 30 times 11. Let's do the multiplication. 1 times 0 is 0, 1 times 3 is 3. Then we have another 0 as our placeholder. 1 times 0 is 0, 1 times 3 is 3. So that's 330. Negative 330. And then 5 times 1 is 5. Now, we can't leave it this way. We need to actually go ahead and simplify. And we're going to simplify by using division because the fraction bar denotes division. All right, so 330 divided by 5. 5 does not go into 3. It does go into 33 6 times. 6 times 5 is 30. Bring down the 0. 5 goes into 30 6 times again. So this simplifies to 66, but not just 66, a negative 66, because I'm dividing a negative number by a positive number. So how far did it move? It moved negative 66 degrees in 2 1/5 hours. Okay. So our next example says, how many 3/4 or 0.75 pound packages can be made from 6 pounds of sunflower seed? Okay, so the mere fact that we have a certain number of pounds and we want to break it up into smaller packages, that idea of breaking up is division. So we're going to be dividing the number 6 by 0.75 to see how many of those packages we can get out of this number. So we're going to go ahead and set up our division house. Okay, the divisor goes on the outside and the dividend goes on the inside. Now, whenever we're dividing by a decimal, we have to remember our concept of monkey see, monkey do. So I want to convert this 75 to a whole number, and if I do that out there, I also have to do it on the inside. So now I'm working with 75 and 600. Okay. Now 75 does not go evenly into 60, but it does go into 600. So you want to try to figure out how many times. Now, one strategy you can use is to think about this like money. So 75 cents times, or 75 cents plus 75 cents is $1.50. So how many $1.50s can I get out of $6? So $1.50 plus $1.50 is $3. $3 plus $1.50 is $4.50. And then $4.50 plus $1.50 is $6. So in $6, I have 4 $1.50, and in each of those $1.50, I have 2 75 cents. So 75 goes into 600 8 times. And let's check it, right? So that's kind of like a little guess and check. 8 times 5 is 40. 8 times 7 is 56, plus 4 is 60. So that is confirmed that 75 goes into 608 times. Okay. You could have also just picked a number like 4 and tried it, pick a number like 5 and tried it. However you wanted to think about it is fine. Guessing and checking is absolutely okay. So, how many packages can be made from 6 pounds of sunflower seed? You can make 8 packages, with each of those packages containing 0.75 pound. A recipe for trail mix calls for 3/4 cup dried fruits, 1/2 cup mixed nuts, and 1/3 cup granola. How many cups of trail mix does this recipe make? So here we have 3 different measurements, right? And we want to know what's the total amount. So here we're going to add. So we have 3/4 plus 1/2 plus 1/3. Now, you know the rules for adding and subtracting fractions require you to have a common denominator. So we have to figure out what's the common denominator for 4, 2, and 3. And not just any common denominator, but the lowest common denominator. So here it's 12. So we're going to go ahead and convert each of these fractions to that denominator. Now, what number times 4 is going to be equal to 12? That's 3. So whatever I multiply the bottom by, I also have to do to the top. So 3 times 3 is 9. So 3/4 is equivalent to 9/12. 2 times 6 is 12. So therefore 1 times 6 is 6. 3 times 4 is 12. So 1 times 4 is 4. And these are all equivalent. So 1/3 is equivalent to 4/12. 1/2 is equivalent to 6/12. Now to add, we keep our denominator the same, and then we're going to add our numerator. So 9 plus 6 is 15, and then 15 plus 4 is 19. When I look at this fraction 19/12, I see that it's improper, and that means I can simplify further. So I can do this as a decimal, or I can leave it as a fraction. Let's go ahead and see what it looks like. So 12 goes into 19 once. 19 minus 12 is 6. And then I rewrite my denominator of 12. Now this can still be simplified further. So I know that 6 and 12, right, can be simplified. 6 goes evenly into itself once, and 6 goes evenly into 12 once. So if I divided the numerator by 6 and the denominator by 6, then I would end up with 1.5. Okay. Now, what if I wanted to represent this using decimals? What would that look like? What is 1.5 as a decimal? If you said 1.5, then you're absolutely correct. However, if you weren't sure about how to go about this, we can use what we know about division to help us find that answer. So let's go ahead and take a look at how we would convert 19/12 to a decimal. So I'm going to put 19 inside my house and the 12 on the outside. So whenever we have a fraction, the numerator is your dividend and the denominator is your divisor. So 12 goes into 19 once with a remainder of 6. Now 12 cannot go into 6, but the rule for converting to a decimal tells me that I can put a point here and then add a 0. 12 into 60 is 5 times. 5 times 12 is 60. And I have nothing left. So 1.5 as a, 1.5 as a decimal is 1.5. The Darwin D. Martin House, built by Frank Lloyd Wright, has a rectangular stained glass window with a length of 41.5 feet and a width of 26.25 feet. What is the area of the window? Okay, so if we were to sketch this image, right, it's a rectangular shape, and we know that one of this dimension, the length, is 41.5, and that the width is 26.25. what is the area? So first I need to think about, how do I calculate the area of a rectangle? And the area is equal to length times width. So now I can go ahead and plug in my numbers. So 41.5 times 26.25. So now these numbers are a little bit on the bigger side, but we can still work with them just the same. 41 times 2 is 82, plus 1 is 83 over 2, times 26 times 4 is 104, and that's going to be over 4. Now, before we multiply, we can actually see if there's anything we can simplify. So if I look at 104 over 4, I see that that fraction can be simplified because 4 goes into itself once and 4 goes into 104 26 times. So I can actually rewrite that fraction as 26 over 1. My numbers are a little bit smaller. So I have 83 over 2 times 26 over 1. And now I can go ahead and multiply. So 83 times 26. 6 times 3 is 18, carry the 1. 6 times 8 is 48, plus 1 is 49. 2 times 3 is 6. 2 times 8 is 16, and then I add my numbers. 8 plus 0 is 8. 9 plus 6 is 15. 4 plus 6 is 10, plus 1 is 11. So that gives me 2,158. And that's all being divided by 2. So now I'm going to set up that division problem. So I'm going to draw my house. Inside, I'm going to put 2,158. And it's being divided by 2. 2 goes into itself once. I bring down my 1. 2 does not go into 1, so that's going to be 0. And then I bring down my 5. 2 goes into 5 7 times. 7 times 2 is 14, with a remainder of 1, and I bring down my 8. 2 into 18 is 9 times. So when I divide 2,158 by 2, that is equal to 1,079. So the answer here is that the area of the window is 1,079 feet squared. So remember, whenever we talk about area, it's always going to be in square units. Marcia had negative $15 in her checking account. She did a few chores and made $48.50. She decided to pay for her and a friend to go to the movies, and each ticket cost $7.25. How much does she have left in her account? So let's go ahead and set this up. So she started off with a negative $15. Then she earned, right? So the action of earning something is a positive $48.50. And then she went out and spent some money. So that's going to be a minus. Now, how many tickets did she purchase? If you said 1, that's incorrect. She purchased 2 tickets because she decided to pay for her and a friend. So that's going to be 2 times 7.25. So let's go ahead and start our calculation. So based on order of operations, I'm going to go ahead and start with my multiplication. So here I have 725 times 2, right? And it's really a negative 2, but I know that a negative times a positive is going to be a negative, so I can do the multiplication and then just bring my negative down. 2 times 5 is 10. 2 times 2 is 4, plus 1 is 5. 2 times 7 is 14. Now, whenever we talk about multiplying and involve decimals, we have to count the number of decimal spaces. So we have 1, 2 decimal spaces. So in my answer, I need to move my decimal from the right-hand side to represent that. So I'm going to move 1, 2 spaces for a final answer of $14.50. So now I'm going to bring down the rest of my problem. And then because I have pluses and minus, I know based on GEMDAS, I'm going to do addition and subtraction from left to right. So let's start off with our negative 15 and our positive $48.50. The rule for adding and subtracting integers says if it's the same signs, we're going to add and keep. But if I have different signs, I'm going to subtract those numbers and keep the sign of the larger number. So I'm going to set up 4850 minus 15. Okay, 0 minus 0 is 0, 5 minus 0 is 5. Bring down that decimal point. Whenever we add or subtract decimals, we line up the decimal. 5 minus 8 is 3. 4 minus 1 is 3. So here I have $33.50. Now, is that number going to be negative or positive? Different signs, subtract, keep the sign of the larger number. So the larger number represented here is $48.50, which is positive. So I'm not going to write the plus sign because I know whenever I don't have a sign, then that means my number is positive. So let's go ahead and bring down the rest of the problem, which is minus $14.50. So let's go ahead and stack these numbers and set them up. So this is a 5, by the way. Let me just, still doesn't look like a 5. There we go. So it's 33.50 minus 14.50. Okay. 0 minus 0 is 0. 5 minus 5 is 0. Again, we lined up those decimal points. We're going to bring that down. You cannot take 4 from 3, so we're going to have to borrow. 4 from 13 leaves 9, and 2 minus 1 is 1. So there's $19 left in Marsha's account. Okay, so Marsha has $19 left in her account. Thank you for watching and have a great day.